Hello again, and welcome back to CCCS 111 Introduction to Programming. We're continuing today with section 2.6 of our textbook, Decision Making, Equality, and Relational Operators. So, in programs, in more sophisticated programs, what typically happens is that you do not want to necessarily execute every line of code. Some lines of code you want to execute only if, after making a certain decision, only if certain conditions are true. Today we're going to look at how we can do that. We haven't done that so far. So far, all the programs that we have looked at executed every line of code that we put in. So this conditional execution of code is achieved using something called the if statement. And what the if statement does is it checks the truth value of a condition. And a condition can either be true or it can be false. Nothing in between. It's a binary decision. One of two options. So first, let's look a little bit at how we can evaluate the status of a condition. And after that, we'll look at how we can then use the truth value of a condition to for the conditional execution of lines of code using the if statement. So we have a number of relational operators in C, 6 to be precise, and when you use them, the output, the result of evaluating a condition, like I said, can be one of two possible outcomes. Either the condition that you're checking, that you're evaluating, can be true or false. Or in number terms, true sometimes is usually taken as 1 or any non-zero numeric value, while false is taken as equal to 0. So let me show you the relational operators that we have in C. There's greater than, less than, greater than or equal to, less than or equal to, and actually I should jump over here, equal to, not equal to. So this is how you would express those, this is how we express those operators in algebra, if you were doing it on paper. And these over here in the second column are the symbolic, the symbols for these operators as we will use them in our program. So just quick examples. In the third column, if you want to check whether if x is greater than y, you would type that in like this. If you want to check if x is less than y, you would type that in like this. Want to check if x is greater than or equal to y, that would be this one. Want to check if x is less than or equal to y, you would use this code. You would use this expression. You want to check if x is equal to y, you use this, and I'll talk about this a little more. And if you want to check if x is not equal to y, you use this expression over here. Now, notice that for the equal to relational operator, we're not using x equal to y. We're using two equal signs over here. Why is that? Because a single equal sign like this is not a relational operator. That is an assignment operator, meaning that when you put a single equal sign over here, what that will do is it will not evaluate whether x is equal to y. Instead, it will assign the value of y to variable x. And that's not what we're trying to do over here. So the second part of conditional execution of code is the use of the if statement. Basically what it does is the if statement is followed by a condition. If that condition evaluates to true, the lines of code inside the block of code following the if statement is executed. If the condition happens to be false or evaluates to false, those lines of code will not be executed. And here's the example that I'm going to try out for that in the hands-on section for today. So we have a main function over here. We're only going to use the standard IO library. And what this program does is initial starting part should be familiar to you. So we print out two lines, enter two integers, and I will tell you the relationships they satisfy. And we create two integer variables, num1 and num2. That's followed by a scanf statement. Of course, we have to read in those two integers, and instead of prompting the user to enter one number and then the second number, instead we're going to save ourselves a little time and a little bit of code space and a few lines of code, and we're going to use a single scanf statement to read in both num1 and num2 integers. And in what format is the user going to give those two integers? That you can see over here in the first argument of the scanf function. Remember, of course, that it says scanf function on this slide. Because we're using Visual Studio, we are, of course, going to use scanf_s function. So look at the first argument, and it says the string is %d space %d. So basically the user will be expected to enter one integer, a space, followed by the second integer, and will then hit enter. And what the scanf function will do is it will try to interpret, it'll expect to see two integers separated by a space. And this way, as you can see, we can read in two inputs in a single step. You could do that, of course, with as many inputs as you need, 3, 4, 5. And so far, everything up to line 15 is old stuff, should be familiar to us from before. Now here comes the new part. On line 17, you see the use of the if statement. And what we're going to do is we're going to try out all the relational operators in this code. So first, we're going to check if num1 and num2 are equal. And for that, we use the if statement followed by a condition that we put inside these parentheses, and we want to check if they're equal. So we use the comparison operator num1 equal to num2, and the lines of code that will or will not be executed depending on whether this condition is true or false is just a single line of code over here, a printf statement. So if this condition, if the two num1 and num2, if both variables are equal, we're going to print out num1 is equal to num2, followed by a new line character. And that's it. And but remember, this is not the only relational operator we want to test out. We can do something very similar for the not equal to comparison. We can perform a less than, greater than, less than equal to, and greater than or equal to comparisons. And all of these have one printf statement in the if block, and it prints out num1 is not equal to num2, num1 is less than num2, num1 is greater than num2, num1 is less than or equal to num2, num1 is greater than or equal to num2, depending on whichever of these 1, 2, 3, 4, 5, 6 conditions happen to be true. And here are a couple of there's a sample of outputs that you can get. So let's say we run the program first time. We enter 3 and 7. So what we'll see for the output is, 3 is not equal to 7, 3 is less than 7, 3 is less than or equal to 7. So 3 of those conditions, if conditions, will evaluate to true. Second example, we entered 22 and 12 as input. In this case, we see 3 other statements print out. 22 is not equal to 12, 22 is greater than 12, 22 is greater than or equal to 12. And in the third example, we input 7 and 7 as the 2 integers, and that also produces 3 statements. 7 is equal to 7, 7 is less than or equal to 7, 7 is greater than or equal to 7. So this is an explanation that I just gave you, slightly more detailed. So let me just jump ahead to something. So important to remember here with the comparison operator is the difference between it and the assignment operator, single equal sign. Don't mix those two up. Okay. Saw this a little earlier. This is the order of precedence, the order in which C will evaluate different operators if you have a very long expression. This is where the relational operators fit in the order. Other than that, you'll see that as we go along, we will see more and more keywords that are part of the C language, and it is necessary that we definitely have to remember those, because as C keywords, these are words that you cannot use as identifiers for such things as variables. And here's a list of all the keywords in C. So some of these we have of course already seen. So for example, you're already familiar with the meaning of float, double, char for character. You're now familiar with if, int, long, return, short, signed together with any of the other variable type, one of the integer numerical variable types, size of, and void, of course. and corresponding to signed, there's unsigned. The other ones, I hope we will get to all of them. If not that, then most of them. So yeah, so look at this list. If I mean, I hope these will probably make for bad variable names in any case, but it definitely cannot name anything, any variable or anything else. You cannot give them names from this list of reserved keywords of the C programming language. Now, at the very end of this chapter, before moving on to chapter 3, there's one other thing I would like to say about the printf statement. Just like we have seen that the scanf, there's a secure version of the scanf statement. Just like that, there's also a secure version of the printf statement. And the thing is that the printf statement can be exploited for attacks on systems. And a better alternative to the printf statement is the puts or put-s or put string statement. So what does over here is basically, if you have a this printf statement over here, the equivalent of that using the puts statement is this, and we'll see a slight difference right away. The new line character. So puts automatically inserts a new line character at the end of whatever string you provided over here. If you absolutely need to print something to the console that should not have a new line character at the end, you can't use the puts statement. You can't use the puts function. Sorry. Instead, there's a workaround for that, still using the printf statement, printf function, and that's this example over here. So instead of, let's say you want to do this, you want to print welcome space without a new line character at the end. The safe way of doing that using the printf statement would be this way, and %s over here is a placeholder, just like %d, %f, %ld, %c, which we've already used, and %ss. The s over here stands for string, and the string that we're going to substitute over here is whatever string we provide in the argument over here. In this case, welcome space, the same string we have up here in the non-secure version use of printf. So this is a workaround for if you do not want to put in a new line character at the end of the string. If you do, just simply stick with the puts function.